Hello everyone, this is Mr. Appel, and today we're going to learn a little something about isosceles triangles, the Isosceles Triangle Theorem, which is going to open up a whole new world to you. A whole new world of isosceles triangles. Okay, here we go. Enough of that. So, to start, I'd like you to just make a rough sketch, it doesn't have to be perfect, of this triangle, and then I'd like you to take that triangle and reflect it over the y-axis. So I'm going to ask you to pause, do that, and then write down everything you know about the two triangles, the original and the new one that you reflected, and anything else in this situation. So go ahead and pause and do that. Okay, so let's see what we've got here. You should have that triangle, so it should look like that. And some of the things you should have written down, hopefully, if you missed any, you should write them down, is you've got these two triangles have to be congruent because reflection is a rigid transformation, which you may remember from our study of transformations means that the original figure and the transformed figure are congruent to each other. Same shape, same size. So this side and this side have to be congruent, and this side and this side have to be congruent. And this angle and this angle have to be congruent. This angle and this angle have to be congruent. Lots and lots of good stuff there. The other thing I notice, and we'll see if you notice this as well. Let me make that a little bit thicker in here. Whoops. The other thing I notice is that if I look at it, I actually have one big triangle if you put those two together. And in particular, I have an isosceles triangle because these two sides are equal. And what I notice is that isosceles triangle, these two angles are also equal. And that's what we're going to be exploring today, is what happens in isosceles triangles. Okay, so first let's look at some vocabulary that you need to know about isosceles triangles. So you should be jotting this down and writing all of this vocab down because you really need to know it. First of all, in an isosceles triangle, the two congruent sides are called the legs. I know that an isosceles triangle can have all three sides congruent, right? Because we said the new definition is at least two. But in general, when we're talking about it, we mean the two congruent sides. So those are called legs in the triangle. The third side is called the base. And know that this is true even if this thing is turned sideways or up on its head. The base isn't the bottom one. The base is the one that isn't congruent to the other two. Then the angles also have some special names. The two angles opposite the congruent sides. So those two angles there are called the base angles. And again, they're opposite the congruent sides. So if I have this side and this angle, they're opposite. They're far away from each other is what we're thinking of. And then this angle and this side are opposite each other. Okay? And then finally, we have that angle up at the top, which we call the vertex angle. That's sort of the angle between the two congruent sides. So what this brings us to is the Isosceles Triangle Theorem. And basically what it says is, and you may have already sort of known this or just known it intuitively, is that if the sides are congruent, in other words, if it's isosceles, if the triangle is isosceles, so if these two sides, for example, are congruent, then the opposite angles are congruent. So this angle and this angle, the base angles, must also be congruent. So the Isosceles Triangle Theorem says if the sides of two sides are congruent, then the two angles are congruent. Okay. It also works in reverse. That's the converse of the Isosceles Triangle Theorem. And that just says if two angles in a triangle are congruent, so let's just say angle B and angle C, if I know those are congruent, then I know the opposite sides have to be congruent. So this side and this side would be congruent. So if we're using that in a proof, you can actually just use the names. You can call that first one, this one, the Isosceles Triangle Theorem, would be how you know those angles are congruent. And if you're doing it in reverse, you could just say converse of the Isosceles Triangle Theorem. Or you can write it as an if-then statement. Okay, let's just look at one example of how we can apply this. So this is where the whole new world comes in, because here we have a triangle, and we only know one of the three angles in the triangle. And up until now, we couldn't solve a problem like this. But we have some extra information, namely that these two sides TH and TO are congruent, and I know that because of those hash marks. So this is an isosceles triangle theorem, and by the isosceles triangle, it's an isosceles triangle, and by the isosceles triangle theorem, the base angles must be congruent, the angles opposite those two sides. So this angle H must be congruent to angle O, so we can now solve this problem. Algebraically, what I could do is just call this X, which means this also has to be X because they're the same, and then say that 2X plus 22 equals 180, and we could just solve that equation. Subtract the 22 from both sides gives us 158, and then divide both sides by 2, and we get, what is that, 79 degrees. And we can actually solve this problem where we couldn't solve something like it before. If you didn't want to write an equation, you could do that problem, basically would be doing the same thing, which would be to say that subtract the 22 from the 180 to get the 158, which leaves you with the remaining two angles, and then just divide that by 2 to get 79 degrees for each of those angles. Whichever way makes sense to you is fine. And that's it. Good luck.